A body is pulled on a smooth horizontal surface with a rope at 30 degrees to the vertical. If the effective force pulling the body along the horizontal surface is 15 Newton, calculate the tension on the rope. So let's try and interpret this question. A, we have 17.3 Newton. B, we have 20.0 Newton. C, we have 30.0 Newton. And then we have 13.0 Newton for D. So let's try and interpret this question. We have the smooth horizontal surface like this, and then we have a body, let's say a block, right? That is pulled. This is the vertical, right? Let's call it Y. And this is the horizontal. Let's call it X as usual, right? They said pulled on a smooth horizontal surface with a rope at 30 degrees to the vertical. So 30 degrees. So let's say this is the rope. This object is being pulled at what? 30 degrees with the vertical. If the effective force pulling along the horizontal, so F of X is equal to what? This is along the horizontal. That is why I'm writing F of X is equal to what? 15 Newton. What calculates the tension on the rope? So if this place, the angle between the vertical and the horizontal is 90. So if the angle between the vertical and the rope is 30, this other side will be 60 degrees. And now they are asking us to calculate the tension on the rope. The tension on the rope along the horizontal will be equal to what? Okay, F of X is equal to T cos theta, because we are talking about what? The horizontal. The horizontal is always cos. The vertical is always sine. So if this is what we have, our tension will be equal to what? This force on this object is a combination of the tension on the rope and the angular distance, right? The angular distance is cos theta. So from here now, what is our tension? Tension will be equal to F of X over cos theta. Tension is equal to, what is F of X? 15 divided by cos, what now? 60. What is cos 60? What is cos 60? Cos 60 is 0.5. So we have what? Tension equal to 15 divided by 0.5. 15 divided by 0.5. 0.5 is the same thing as 1 over 2. When you turn it upside down, it becomes what? 30 Newton. So do we have 30 Newton in the option? Yes, 30 Newton is C. So the tension on the rope when you're pulling this object at an angle 60 degrees to the horizontal is 30 Newton. You know, when you're pulling a rope, there is a tension on that rope. Apart from the force that you're applying to stretch the rope, there is a tension on the rope by virtue of your stretching. So that's what we are trying to calculate. And in this case, it is what? 30 Newton.